Hey guys, I hope that you would be doing well, that you would be great, okay? So in today's video, we are going to find continuity of this function. We have to show this that is this function continuous at this given point, okay? So if you want to find continuity of any function, in today's video I'm going to show you the three steps, and these steps can be applied to any function if you want to find the continuity of that function at a given point. So in this video, I'm going to find the continuity of this given function, which is a compound function, because there are two equations, which is the one is this and the other one is this. So there are two equations, so this is called compound function, and I'm going to find continuity of this compound function at this given point, which is x equals 0. So there are three steps to find continuity of any function. The first step is we have to check that is the function defined at the given point. Okay, so the given point at the given point is x equals 0. So we have to check that is the function f of x defined at this point x equals 0. So let's do this and let's check is it defined or not. So when x equals 0, so as here in the compound function, as you can see that f of x equals 1 when x is 0. Okay, when x is 0, so the f of x function is equal to 1. So f of x is equal to 1. So it is defined because 1 is a real number. Okay, it is defined because 1 is a real number. So the first step is true. Now move to the second step. Okay, so now we have to find the second step, and we have to prove that is the second step true or not. Okay, so the second step is to find the limit of a function. Okay, at this point. Okay, so limit of a function, we have to find limit of a function at the given point. So limit x tends to 0. Okay, in the previous video I have told you when we were finding limit of any function, and I told you that when x approaches 0 or when x tends to 0, it means that x is not exactly 0. Okay, x is very close to 0, but x is not equal to 0. Okay, this is the case, x is not equal to 0. So this is the case for the continuity of this is the case for the limit. Okay, so this is the case for the limit. When x approaches 0, it means that the x is very close to 0 but not exactly 0. Okay, so as you can see here in this compound function, when x is not equal to 0, the function f of x is equal to sine x by x. So now I have to put it over here, sine x divided by x. Okay, so you would be thinking that when I apply limit, so it would be equal to 0 by 0, because sine 0 is 0 and divided by 0. So this is 0 by 0, which is an indeterminate form. We have to convert this into a determinate form, but we should not, because it has been proved. Okay, this given function, the sine x by x, it has been converted by others to a determinate form, and the final answer was 1. We don't need to solve this, we don't need to derive this. If you want me to derive this, so we will do this in the future videos, but for now we would just say that limit x tends to 0, sine x by x is equal to 1, because it has been proved. Okay, so this is equal to 1, so limit exists. So yeah, the first point true, which is we were finding the definition. We were finding that is was the limit, was the function defined at that point. The second is finding the limit. Okay, is the limit does the limit exist? So it does, it exists. So both points are true. Now move to the last but not the least point to find the continuity of any function, and that point is to check the equality between the answer from the limit and the answer from the definition. Okay, we have to check that at the given point. Okay, the answer is 1. Is this answer and this answer, are they both equal or not? If they both are equal, then we say the function is continuous. Okay, if they are not, then we say the function is not continuous at that given point. So as you can see that both are equal, because the answer from the definition is 1 and the answer from limit is also 1, so they both are equal, and it means that the function is continuous, because all of them, the 3 points, they all are true. Okay, they all are true. If one of them was wrong, I mean if one of them was not proved to be true, then we would say that